So here's a few news articles. First one, of course, is that we won the penetration testing championship. This is fantastic, beating all these famous colleges like Stanford. So it's amazingly good work on the part of the team. And this weekend, I'm going to get them together and record a video where they talk about their experiences here and what the contest is like and how they got there. So people who are interested can watch it, like potential competitors or outsiders who just want to understand this. This is a really good contest, and it is amazingly good that we won it. I never expected us to beat Stanford, but we did. So they're going on to the finals in January. It's now an international contest too. They had a Middle East team, and I have a Middle East region and a European region. So it's an international penetration testing contest. Anyway, Trump's website was hacked briefly. Just one page on it, not the main page, the about page. So this looks like a fairly common content management system hack, or a SQL injection, or a PHP uploader that can upload to a file or something. They were able to put up a page with like some insults about Trump and some requests for people to send them cryptocurrency, but apparently it was only up there for a few minutes before they caught it and brought it down. So this is a common trick. And of course, it doesn't really mean much of anything in the world of cybersecurity, because a campaign website is not important. It's not like they actually hacked an official US government website or something. Campaign websites are put up, hastily by volunteers and stuff, and not as important. But, it's a sort of mild embarrassment for the Trump campaign, especially since Trump recently said nobody gets hacked. But, as we all know, everybody gets hacked, and you have to do threat modeling. You can't stop all the attackers. And so if you have a lot of people angry at you like Trump, then they'll find the weak link. And if you're a well-organized company, it's not that you won't have any weak link, it's that your weak link will be something not very important, where it's not too bad when it gets hacked. So I didn't know Microsoft is doing this. Microsoft is putting out an update that will remove Flash from Windows and block it so it can never come back. But it's an optional update. So that's interesting. I think the point is for corporations that would like to prevent people from having Flash and be sure it's not there, which is a really good idea because Flash is so insecure. But of course, one minor detail is it totally doesn't work. If you do find that update and put it on, it doesn't remove Flash like it's supposed to. So these guys are complaining to them. However, anyway, if I was running a company, I probably would like to push out that update to get people to not install Flash. It's very commonly fake anyway when people offer you Flash. So here's a new attack that's very much like the DIL replacement attacks we've been doing in this class. It looks a little complicated. So if somebody wants to figure this out, it'd be worth extra credit. And I might decide to make a project out of it. I'm not sure. But what he does is he, when you load a file on the disk and you execute it, it copies it into memory. So then he comes back and changes the file on the disk so that the image in memory is running. But when something like your antivirus looks on the disk, they're going to find different stuff which they regard as innocent. So he calls this herper-derping. And it seems like an interesting issue. When you do the opposite, they call it process hollowing. When you run a file, put it in memory, and then you change the contents of memory. They call it process hollowing. This is the opposite. Anyway, it sounds pretty cute, and it looks like it uses all the techniques we're talking about here, hooking these Windows API calls and tricking it into misunderstanding what's on the disk. So it does look like it totally belongs in this course. And I'll take a look at this, and I might figure it out. He's using the tools we use, and it's another version of the technique. So it might be interesting. All right. Starlink is coming out. This is Elon Musk's new free internet, or cheap internet. He's going to put up a whole bunch of low Earth orbit satellites and then sell internet around 50 megabits per second to people so they can get it even if they can't have a cable going where they are. So it'd be good for people who've been using satellite internet in the past. This is much better than the existing satellite internet. And so we'll see what happens. The first beta is up. He's only put up the first few satellites. There's a lot more satellites coming after this. All right. The British study has shown that the immunity to COVID-19, if you have had it, fades significantly in a few months, which would make it about the same as the previous COVID, the common influenza that we had. Common influenza, you get the same thing every year. After about a year, your immunity has faded and you can get it again. So that is not really a surprise in the grand scheme of science. Of course, a lot of people Wanted to hope that was not true, but we do have several confirmed cases of people getting COVID-19 twice. So there were some clues suggesting that it was going to be like the common flu, and apparently it is. And that means, I guess, you're not only going to need to get a vaccine, but you're going to have to get booster shots periodically, the vaccine, or something like that. Anyway, it's interesting information. Of course, this is all preliminary stuff. They've measured the level of an antibody in the blood. They have not really proven how much it helps you resist the disease anyway. They don't even know that the antibody successfully fights it off, or that as it falls, it stops fighting it off. You know, it's all early days. So there's this I think was done with a survey, and it shows something which I think a lot of us know, which is people are very frustrated in the world of security. You can pay a lot of money, buy a lot of hardware, install stuff, hire highly qualified staff, and then you still get hacked. It's very annoying. And when they ask people, how happy are you with your products and services in the world of security, they're typically pretty unhappy. You know, everybody gets hit by ransomware, even though you're running defenses, and you know, it's very hard. It's like, you know, being in a really bad neighborhood of town where burglars are breaking into your house all the time, and you're trying to do something about it, and you're not very successful at getting it eliminated down to zero. So that's why they have to hire so many of us, you know, and it's job security for us. But, you know, it is a sort of absurd situation and frustrating for people that have the responsibility of protecting networks. You know, even if you raise enough money and buy a high quality product, it still doesn't make you very safe. So that's the way we are. There are a couple interesting articles from Cyber Gibbons here on hardware hacking, which is kind of good fun. So if you have some kind of hardware device, like an Internet of Things device, like a webcam or a router or something, it's running firmware, but they don't really want you to get the firmware off it. And so there are tricks. You can get a shell sometimes, you can connect with a serial port and so on. And then there are ways to get the firmware off the device. The firmware is really very small. So it's like 16 megabytes. And once you get it on a Linux machine, you can then unpack it and analyze it and get it into IDA Pro and use the kind of techniques we're using here to figure out how the firmware works. I've wanted to have a hardware hacking at City College for a while. We have a couple of people there that are really, very good at this, and it might fit into the car hacking class people are talking about writing, but none of those are available yet. They're coming in future years, but I've done a little bit of this, and it's a lot of fun. All these little devices are running is highly compressed, stripped down Linux, very simple Linux. And you get a file, you unpack it, and then you can go in there and find things. So he talks here about how to get it off the device, which is your first issue. The universal solution is a JTAG. You actually take apart the hardware and solder on a special chip to suck the firmware off a device. But you can often do it without changing the hardware by sending it out through a USB port or over a serial port or over an Ethernet port in a variety of ways. And he talks here about a few techniques to mount a USB device in that file system and copy the firmware, or to copy it using TFTP, a simple file transfer technique. If you can get a network connection, these will often work. All right, and this is going around the news quite a lot. This is a researcher that had measured a number called the political stress indicator, because, you know, I think everybody's very upset about the political situation in America. It is ridiculous. And the people on the left, like me, feel like we need to get rid of Trump. But of course, as I've always thought, that doesn't really fix the problem, because 40% of people voted for Trump. So, and I remember 5 or 6 years ago, I was talking to a student, and I said, well, you know, there are Nazis in America, but they're only 1% or less than 1%. They'd never actually get any power. And that's not true anymore. So the question is, what is the underlying problem that makes people so crazy that they will believe conspiracy theories, deny that there's a virus, put a guy in charge that's just lying to them and robbing them? And, you know, that's like in Palestine, where people are so desperate they actually just go and blow themselves up. Because, so this is, he's trying to measure that here. There are wages have gone down. People don't feel represented. People don't see much future. And so they have this political stress indicator. And he says our stress is reaching a really high level, like it has in the past, times of great stress like the Civil War. He doesn't have the Vietnam War in here. I know I lived through that, and that was a time of enormous stress. And it also had a feature we have now where one generation has no communication with the other generation, and they just live in different worlds and believe different facts and cannot agree on anything, which we have now. Anyway, it's we'll see where this goes. And then people argue, how bad is this crisis coming? But, you know, getting rid of Trump seems like an improvement, but it certainly doesn't solve the underlying problem. A lot of people in America are apparently enormously unhappy to where they're willing to elect a guy like Trump out of a sort of desperation move. And we really need to somehow meet their needs so they're not so desperate, or we'll just have somebody else go in again doing something similar. Anyway, we're up to this here, chapter 11. All right, malware behavior. And some of this is fairly ordinary information about malware, and then it gets more technical, so there's some good stuff here. All right, so types of malware you get, there are downloaders and launchers. Malware typically comes in stages. You will find a vulnerability and be able to do something simple like execute a few lines of command line. And those lines of command line will be something like an FTP to download another piece of code, and that code will launch something else or download something else. You typically have stages of infection. So downloaders are one common thing where when this runs, it will connect to the internet and download another file and run it. So it might use API calls like URL download to file and winexec or many other techniques to just make API calls that download it. And then there are launchers. And a launcher is where you have something malicious, but you don't want to just directly download it and run it because, for example, it's obviously malicious and it would set off the antivirus. So you want to run something without getting it into execution in the normal way. So what you do, and I used to do a lot of this in Python to get past antivirus, you put it as a data file. You take your executable compiled code and you store it as data. And then you just load the data into memory as a variable that pretends to be like a string, and then you jump into it and execute it. So this will fool antivirus, even modern antivirus. It's an old trick, but it still works very often. It doesn't actually come in as an executable at any point. It isn't really treated as an executable. And so it bypasses the antivirus signatures. And that's the sort of thing you do here. You store the malware someplace like a resource section, and then the code just copies that into memory and runs it. So there's a couple of categories of malicious code. Then there are backdoors. Backdoors give you some kind of access to the machine. The simplest backdoor is, of course, just create another account on the machine. And then you can log in, but of course they usually do more than that. They usually listen on a network port and let you execute commands, run arbitrary code on the file, download things, upload things, and so on. What you typically want to get is a reverse shell. You get control of the machine, and then you want to export a shell. This is the way you could do it with just ncat, which comes with nmap. You connect from the target machine to a server on outgoing port to port 80, so it will look to your intrusion, your network monitoring, like an outgoing web request. And then you run cmd.exe, so it now listens and executes whatever comes back as a shell command. This is one simple one-liner to make a reverse shell, and there are many other ways to do it with Metasploit and so on. But the point is, there's two important points here. The first thing is you get the ability to execute arbitrary code on the server, which is what you want. And the second one is the connection initiates from the inside. So it is the infected machine in the company phoning out to a command and control server, because if it was the other way, some unexpected traffic coming in, it would probably be blocked by the firewall. You want it to be initiated on the inside and going out, because then it just looks like somebody opening a browser and going to the web, and that's almost always allowed. So that's why they call it a reverse shell. And that's why years ago, when Windows XP came out with the Windows firewall, there were about 20 or 30 common firewalls people used, and I saw a test rating of them. And they rated them on a scale from 1 to 1,000, and they gave Windows Firewall a 0, because all the tests involved making reverse shells, and the Windows Firewall in its default configuration does not block any outgoing traffic. It only blocks incoming traffic, and so that's not good for reverse shell. Anyway, so if you want to do this in API, you could create process and have the start info structure specify details of the process, so it will create a socket. And you have to have one socket for standard input and one for output, and possibly one for error, unless you want to throw away the errors, which is an option. And then it'll run cmd.exe. You can suppress the visual window so nobody will see commands going by, and now the attacker is executing command lines on the server. All right, you can do it with multiple threads, 2 pipes and 2 threads. So one pipe is for input and one pipe is for output. That's another way to do it. Any way you do it, you have these infected servers. They're phoning home to the command and control center under the control of the attacker, and they're just performing various actions. They're looking at a control panel and sending out commands, really placing commands on the server, which the clients then reach out and harvest, and then they execute those actions. So that's called a botnet. You're a bunch of machines under remote control of a criminal. I've seen estimates that up to 11% of corporate machines are owned. I don't think that's true anymore, but I think that was true about 10 years ago. So a rat is the software you put on one machine, a remote access Trojan to give you control of that machine, and a botnet is the network of machines that are owned. They're typically not owned just by rats, though. They're typically owned by rootkits because you want persistence, and we'll get there. Anyway, then there's credential stealers. Once you get on a machine, you want to steal all the passwords you can find off that machine, and Kerberos tickets and password hashes, because you can use those for lateral movement to move on to other systems to try to authenticate with them. And the Windows doesn't like you doing that, so you have to download special tools to do it. Now, there are other techniques. Before Windows Vista, Microsoft had a technique called Gina. Microsoft Windows supports alternative authentication methods. In the early days, you just had to type in a name and a password, but there are handicapped people who can't type in a password and they want to do something else. There are people who want to use a pin, or they want to use a shape they trace out with their finger or their face or their voice print or their thumbprint. And there's just an endless chain of alternative ways to authenticate. And so Microsoft has developed ways to support them. And the older technique in Windows XP was Gina, graphical identification and authentication. And so this msgina.dil would be a library. And when you hit win login, it would go to Gina, and Gina could tell it to use some other authentication technique. So you could just hijack that DIL, just like we've been doing. Your Windows logon tries to load msgina, and you could intercept it and have a malicious DIL so it does something unusual. For example, like making an extra copy of the password somewhere, so you're stealing the login password. That's what could be done here, and that's a man-in-the-middle attack. And I think the same technique we've been using in the DIL proxying would work just fine, but I don't have an old Windows XP machine to work on, and that's not that important anymore. Anyway, that's what they do. Take the calls to msgina and run them through a hijacked file, so you steal the data. Now, Gina is not around anymore. It's been replaced by something called credential providers. And these appear here in these registry keys. But it serves essentially the same function, and there is a similar attack. At the time of Windows 7, this was the most effective attack I could find. They weren't able to replace the login buttons with malicious login buttons, but they were able to make a second set of login buttons. These ones go to the wrong credential provider, and you'll end up having your credentials stolen. And probably it wouldn't be too hard to find some way to conceal these so you don't see them, and you log in through that one. Anyway. And then I mentioned before, for hash dumping, you can't, now in Linux, as you know, you can just go to etch shadow and you'll find the password hashes. But in Windows, you can't do that. In Windows, they have made it so that even the administrator account is not allowed to access the place where the hashes are stored. You have to use a tool to get in there. One of the common tools is Kane. It'll dump out your password hashes. Here's the old LM hash that is just a placeholder. It doesn't have any information anymore. And here's the Windows NT hash, which is what Microsoft is really using. And you notice the first three are identical because I created those accounts and they all have the same password. And one of the many appalling defects of Microsoft's hashing system is that there is no salt. So if two users choose the same password, they end up with exactly the same hash. So if you do get Windows password hashes and you want to crack them, you can usually just Google them. You don't need any tool at all, because since 1993, Microsoft has never changed their algorithm. So for 25 or 30 years, everybody has been just building libraries of known hashes, and you'll probably just find it by Googling it. They are 1 million times weaker than Linux password hashes. If you take the pen testing courses, we play with that. It is appalling. Microsoft's cryptography for hashing is incredibly out of date. Anyway, all right. So to get them, you have to use, there are tools out there like pwnump and Hash the Hash Toolkit. And these will, of course, be detected by antivirus, so they're often modified in small ways just to pass the antivirus. But the way they work is they do DIL injection into the local security authority service, which is the service that has the privileges to read those hashes. And you, even as the administrator, you do not have the privilege to directly access them, but the service can get at them. It has to test to see if people have logged in. So you use an injected DIL to get in there. And that's the technique they both use. PM dump injects a DIL into LS hash and calls get hash. And there's a variant that uses other libraries instead, SAMServe and Advanced API 32 and so on. And notice, by the way, when you've really gotten into the weeds, when you start finding Microsoft API calls like System Function 25 and System Function 27, which I think those are actual, I'm not sure if those are in the malware processor in Microsoft, but Microsoft does have names like that. When you get into the really nasty API calls that are not supposed to be used by anybody except internal Microsoft workers, they're in there, the undocumented calls. Anyway, so here it is calling all these API functions. And then there's a thing called the Pass the Hash Toolkit, which does something similar, injects into LSASS to get the hashes, and uses different calls, LSA, enumerate login sessions. This is local security authority. I think so. Anyway, these are all do very similar techniques to get into the system processes and steal those hashes. So let's try this Kahoot, which is here. And it is 11A, 126.11a, okay. I'll wait a bit. I think there's more coming. All right, I guess that's it. All right, poison ivy, what's that? It was in the slides, I didn't mention it though. Poison ivy is a rat, remote access Trojan, one of the ones that was quite popular back in the days of XP. All right, which one puts malware in the resource section? That's a launcher. That's a common technique. All right. Not a downloader, but a launcher, where it contains a second executable inside it in a non-obvious way, which it loads and runs. All right. Which one will cause the infected machine to send out a SYN to the attacker? Okay, that's a reverse shell. You make a TCP handshake originating from the inside. All right, which technique is no longer possible? Gina is out of date. All right. All right. Which one puts a DIL into LSASS? Both of these password dumpers work that way. So it's more than one of them. All right. All right. UJ might be initials. If not, you better let me know. That looks, MFEL looks like initials. Anyway, all right. So let's go to here. All right, so then suppose you want key logging. You want to catch every key press before it is processed by other things so you make a record of it. Now, putting it in the kernel would be nice. You'd have to make a malicious driver that runs in the kernel, and then it will not be visible to user land code and so on. So that's the strongest way to do it, and that would be part of a kernel mode rootkit typically. You can also do it in user space, where you catch it up there. This you can do with hooking or polling. Hooking, Microsoft has functions to hook a call so that whenever it's going to call an API, it'll go call something else first. That's why you just like the dynamic loading of libraries, Microsoft has a lot of ways where you can add code to a running process, which of course is very handy for attackers. And of course, the reason it's there, it's also handy for people who want to develop new features like some new kind of keyboard or something. You can hook the keyboard capturing process. Ah, I see a name, good. Let me record this name. Good. All right. All right. And all right, and polling is the other way to do it, where instead of catching the event caused by a key press, you just catch the static condition of the keyboard. And so you'll have to just strobe it many times per second, seeing if a key is up or down. That's another way to do it. More laborious, but another way to do it. So if you're polling, then you'll be getting the asynchronous key state, and then you'll be getting the window to try to figure out which window is being affected by the key streak. And eventually you'll be able to put those clues back together to figure out what they're typing, but it's pretty unreasonable. So you have to call get foreground window, and then make a note of which window it is, then call the key state, then check for shift and caps, then try to log it, then try it for every key one by one, then go back and do this. So it's really a lot of work to do that. All right, I remember I've actually done this kind of thing in Android keyloggers that I've written to hack into Android apps. It's pretty burdensome. Anyway, well, I see who UJ is, good. Make a note of it. All right, anyway. All right, so if you want to detect these, if you look in strings, you'll see these special strings, of course. You have to somehow represent these unusual keys, and you could do it in a non-obvious way, but they usually just put them in an obvious way. So that's one way to detect it. All right. And so persistence is what I was referring to before. This is the difference between just having code execution on a machine and really owning the machine long-term to where it's a bot and you can continue to use it for days and weeks. That means you have actually infected it with something that is persistent. So at least it survives restart, people logging off, and so on. So you typically go to the registry and you just, the registry is one of the many places in Windows where there are many records kept to launch extra software when you run things. So you take any of those are the auto start extensibility points, things that will automatically launch when common things happen like a reboot or a login. And here's some of the places you go. The run key, we talked about, there's a couple of run keys and a couple of run once keys that will automatically run code when you reboot. And there are the other ones here, the various kinds of places where you can put DILs that will be automatically launched frequently, or you can modify binaries or DILs that are just normally used in the process of booting up or running the machine. So the run key is here. There are others, and you see them all in auto runs. And you just put keys there that point to executables and they're automatically run. Process Monitor will show this. When you've done this in the projects, you run the malware and you look in Process Monitor and you see it writing to the run key. And all these techniques, you can see them in Process Monitor because they all involve changing the registry. So you'll see it going in here and writing to the file, opening a key, querying a key, and so on. Here's one of the projects you did a while ago. And you'll see it writing to a run key. I don't think there's one on the screen here, but it's pretty obvious. Now, the app init DILs are DILs that alter the modification of user controls. So almost every process loads user32, which contains the user interface to open up windows and have boxes and stuff. And so you can put DILs there, and all those DILs will be loaded into every process that uses user32. So that's handy. And therefore, all you have to do is do something like use Metasploit, like we did before, and make a DIL where the malicious activity is in DIL main. And as soon as that DIL is loaded, it will perform the malicious activity. You don't need to change any code or call a function in it. You just need to trick it into loading it. And that's as simple as just putting its path to it here, or maybe just the name. I'm not quite sure the format. All right, so by the way, app init DILs Microsoft is aware of their being a bad idea, and they're beginning to get deprecated. So they're disabled by default, although there's some way to enable them. Now they support code signing, so you can set it so it'll only accept signed DILs, which would be a good idea. And they say, according to Windows 8, Windows 8 now has something called Secure Boot, which you can turn on. And if you do that, then it turns this off. There's also a Microsoft product you can put on your machines, which I've forgotten the name of, that makes a client machine as secure as a server machine by turning on all the settings that would be on a server, and it turns off all these goofy things. Anyway, but a typical home machine or a laptop desk endpoint at a company that isn't trying hard to be secure might very well still be vulnerable. Because I thought maybe I should stop talking about it, but I looked and there are blogs from just a couple months ago of people using app init DILs on Windows 10 to hack in. So even though Microsoft is attempting to deprecate them, they are still supported in modern versions of Windows, and there are ways to use them. This is very common. One of the huge advantages as a company is that Microsoft software supports legacy code, even legacy code from a really long time ago. So these old, obsolete techniques often continue to work far longer than you would think they would. Anyway, then there's winlog on notify. Here's a notify value you can put here, and then it will be used when you log on. So you can launch code at events like login and startup and so on. And then there's service host DILs. We've looked at these before. If you open up Process Explorer, you see all these SV host processes. And each one of these is running the SV host executable, and each executable is loading a whole bunch of DILs, which run all these background services. So all these services are running from one service host. This is the main thing that's running all the background services. And this list of things to launch is just in the registry. So you can just add your code to one of those lists, and it will then launch your code in the background as yet another service. So here's the service host list. Here's all these things: the local service, network restricted, no network, network service. And here's all the things this particular one is going to load. So it's just a library of things that will automatically launch, and you can just add your code in the list. All right, they have parameters with a service DIL, and that's just a path. This is C Windows, System32, and pointing to some DIL. So it's really pretty easy. And so you add yourself to a group, or you overwrite an unimportant service. Of course, as a typical Windows machine is running about 80 things in the background, and you don't really use very many of them. So there's a bunch of them that aren't important. You can modify them, crash them, break them, and nobody will really care. That's why one thing I used to do when I taught Windows tech support is you have to go into the event log. And a normal machine that's working fine has tons of errors in the event log. A bunch of little pieces of Windows are broken, even when it seems to be working. And tracking down what really caused one of those errors and fixing it can be like a whole week of work. Anyway, I got another Kahoot here, 10B, 11B. Yeah. All right. All right, I guess that's it. Okay, which one's a keyboard driver? Okay, that's kernel mode keyloggers. Drivers are all in the kernel. All right, which one uses get async key state? That's polling, checking everyone to see if it's down. All right. All right, which one of these uses the registry or more? They all do, good. All right. All right, which tool will record the registry modifications? All right, process monitor. We've used it quite a bit. It's really very good. All right, and which item is loaded into every process with user 32? Okay, the AppNet dills, that's what they are. All right. So, all right, Craig and Crazy Pigeon will have to tell me who they are. EH, I think that's real initials. All right. By the way, I'm remembering to tell you about these special events. A bunch of them are coming up. Tomorrow starts the Gray Hat class, and you can just connect to my Zoom and join any of these if you want to. I'll be doing a workshop every day. It's the same stuff you see at here at City College, though. But anyway, if you want to go to that, it's worth extra credit. And then this Cyber Yoda thing is a beginner-friendly CTF intended for high school students, and I highly recommend it. High school stuff is not too easy, not by any means. The high school hackers are very good, and so this should be fun. And then we have a speaker coming, Caitlin. It should be a lot of fun. She showed me what she's doing, building antennas and catching signals from satellites. It looks like fun, and we can all do it too. So anyway, it doesn't apparently cost too much money or isn't all that difficult. So I'll be trying to build that stuff pretty soon as I get a list of materials. But you do have to attend this one live. It won't be recorded and put on YouTube. So check those things out if you like, or any other training event. That's all worth extra credit. Like I told you before last time about this Azure class, and I earned 3 badges, and somebody turned in like 10 badges. So if you just want to learn Azure, that's a really great thing to learn too. You won't be sorry. Anyway, so, all right. So you can trojanize the system binaries where you modify one of the system files, and then it will do something different, like execute malware. So you might modify a DIL at its entry function so that DIL main will run code, for example. Just modifying an address would be enough. Oh, good. And I see a name for Crazy Pigeon. Let me throw this in my, all right. I can't copy it, but I can do this. All right, good. Anyway, all right. And so here's what you have, rtutils.dil. It's got an original code here, which is gonna, this is the typical prologue that creates a stack frame by manipulating the stack pointer and the base pointer, and then it starts executing some code. And instead, you just put a jump here. So instead of doing the real dill, it jumps somewhere else, and now it's doing something different. So that's the start of a modification. So the other thing you could do, of course, which is just what we've been doing, is do load order hijacking. If a dill is not know what directory it's in, then it just hunts through the path, and all you have to do is put a dill with the same name earlier in the path, and it will get loaded. And there's always a series of directories tested, but the first one is the directory from which the application was loaded, and then the current directory, and then it goes to the system directory, Windows System 32, which is probably where the real one is. So you get a couple of good chances to put in fake ones. And we use this technique, among others, to destroy the Iranian nuclear processing isotope separating centrifuges in our attack Stuxnet in coordination with Israel. We used dill hijacking to, among other techniques, to destroy those devices. All right, so known dills registry key is one of Microsoft's defenses against this. It has a list of dills, and it has the complete path for the dills so that when you're loading this dill, you know where to find it. This makes it load faster, and it prevents hijacking, so that's a fine idea. So now you can, but this is something I've learned many years about Microsoft. Microsoft often announces a new security measure, and I think, holy cow, all my attacks are going to stop. But when that version comes out, it's never fully implemented. Like they have address space layout randomization where everything's jumping around in memory, but a bunch of files don't have it turned on and they're not randomized. And this happens all the time because of the same thing I mentioned. Microsoft can't just implement a sweeping change across all their processes, or they would break compatibility with all that legacy code. And it is real important for businesses to be able to keep using their legacy code, so Microsoft is less secure in order to support it, and that's the way it always is. You know, you get more features, more functionality, more convenience, always at the cost of security. But Microsoft is here to make money, and they make the same decision every business makes, that you have to accept some security flaws in order to make money, or you'll go broke. Anyway, so you can only use, therefore, dill load order hijacking only on other dills or ones that are not protected by known dills. So explorerexe, this is the process that draws the start button on your desktop. It's the one that launches as soon as you log in. You'd think it's pretty important, but not all the dills used by Explorer are in known dills. This one is not. It goes through default search. And as we were doing last time, if you just load process monitor and watch it hunt for dills, you can see that a lot of programs do in fact try your desktop or wherever you're launching it from. And that's how you spot one that has clearly not got this protection turned on. There's a lot of them. Found 50 vulnerable dills just in explorer.exe at the time the book was written. There's just a lot. And the problem is, even if they make every dill that's in the import address table of the executable known, dills rely on other dills and rely on other dills. And so you get the problem that I mentioned a lot is supply chain problems. If you write code, for example, in Python, you import a library, ultimately that library comes from some online repository of library code which is not being audited. You don't know who's putting what in there. If you put in Firefox extensions, they're updating from God knows where. A lot of code that you use now just blithely goes off and fetches stuff from some foreign online repository and adds that code to your machine. And when you actually ask, you know, where did all the code on this machine come from and who checked it for security, the answer is really quite disturbing. And more people are trying to, you can buy products now that will try to answer your supply chain issues, that will track down where it all came from and are you really using the latest version and so on. And so it's the same issue here. You load dills, the dills load other dills, and before you know it, you've got this problem. So there's a tool you can get from SANS, command line tool, that will actually look and see if any of these dills have suspicious properties. So that might help. And one thing you do this for is privilege escalation. I've always been astonished since I started using Metasploit, maybe 10 or 15 years ago. Metasploit just has a process called get system. You get a shell, you just type get system, and now your system. And I'm like, this is not right. I mean, why doesn't Microsoft patch these privilege escalation vulnerabilities? But they never seem to. The same old tricks just keep working for years. So you can escalate to higher privileges, which is kind of strange. And so anyway, load order hijacking is often being used. There's a bunch of services running, and the services have to run before you log in, so they have to run with privileges other than the current user, usually system, which is the highest privilege level. So you can use, if you want to terminate a process or create a thread, you need system privileges above administrator. So you can use debug. Turning on debugging because something crashed is one of the ways to launch a process as system. In Windows XP Home Edition, you could just open a terminal and type at 2 o'clock CMD, and it would launch that shell at that time, and it would launch it as system because the task scheduler connected to a process that was running as system. So that was simple enough to escalate that way. They, of course, patched that, but there's a bunch of other ways to do it. So here's how you get a debug privilege. Every process has a token, and the token is like its ID card that specifies what privilege level it runs at. And you can go and call an API call that does adjust privileges on your token. So you add to your token the debug privilege, and now your token has system power. All right, that's pretty awesome. And you can do similar tricks a lot of the time. And this is what happens if you use Metasploit. It has about 5 automatic things it tries when you do get system, and one or the other of them almost always works. And then you got rootkits. The point of rootkits is that they cannot be detected and they cannot be removed by any ordinary process because the rootkit hooks system calls. So now you cannot even do a directory of the hard drive. You cannot even do a list of all the processes, a list of all the network connections. All of those things lie to you. So you do not see the malicious process. That's the point here. And so you can do it from user land or kernel land. And of course, it's more powerful to do it in kernel land, but Microsoft has worked very hard to make that difficult. And as I say, we don't have any kernel mode rootkits just yet in this course on Windows 10. I'm working on it, but it is much harder to make rootkits on Windows 10 than it used to be because Microsoft got tired of this and they put in a lot of defenses. Another thing you could do is just modify the import address table of an executable. So it loads something else. That's fine, but it's pretty simple and easy to detect. And so you have a legitimate program, and so it has an import address table with addresses to call these functions, and you just modify it. So it has this terminate process link, but you make it point to some other code. So now when it calls terminate process because you're doing something like closing this program, it actually is calling that malicious code instead. Simple enough. The other thing you might as well do at this point is just modify the binary of the file itself. You can just modify the code, put in assembly code or compiled code to do something different. One thing people like to do is find code caves. It turns out most code is not compact. There are blocks of space that are not used. So you can just add more code there and jump into it. And then you still have all the original code, but you added a little extra code. This is a little more advanced. You have to add assembly language instruction and put it in there, but it's not that hard. But it's not as easy as this, but it's a little bit tricky. And that's another way to go. Of course, if you have system file checker, you do that on your Windows machine, you'll get caught because it'll check the hash value of all the system files and notice that one of them has been modified. So would Tripwire, but there's always a defense against every attack. All right. Good. All right, I guess that's it. All right, so adding malware to an empty portion of a Windows component. Yep, that's trojanize binaries. We did this to some simple program earlier in the class in Windows. Putty. We added malware to Putty in small ways. All right. So registry key that prevents load order hijacking. Okay, that's known dills. Good. Which one has 50 vulnerable dills? Or at least it did at one time. Explorer, all right. And which hacking tool makes privilege escalation easy? That's Metasploit. Use it all the time in the pen testing classes. All right. And which one changes function code, not pointers? I see. Okay. That's inline hooking, where you take some real code and replace it with a jump. All right. All right. That person I've got already. Okay, 6. And Craig, good. And Juarez, all right, good. All right. So I'll stop the recording and stick around to answer questions.